So in this particular video I am going to give you some tools on inductor and capacitor that may be helpful for solving the network problems in the Laplace domain. Okay, so suppose you have an inductor and initial current is flowing in this direction, say IL of 0 minus, and the impedance is SL. So you can represent this particular inductor as inductor itself SL and a series a parallel combination of current. Okay, and the value of this current source is IL of 0 minus divided by S. Okay, now for your convenient, you can also convert this particular current source into a voltage source. So it will be SL, okay, and a voltage source, and the sign will be this side positive and in this side it is negative. Okay, because current is flowing from top to bottom, means it has to flow like this way. Okay, suppose the external circuit is present inside the black box, so the current has to flow this way, so it will be positive, this side will be positive, this side will be negative. Okay, and the value will be, what will be the value will be voltage equals to current into impedance. Okay, so IL of 0 minus divided by S, this is the current, into SL impedance, so it will be L into IL of 0 minus, right? Okay, now for capacitors, similar thing you can do. Suppose this is a capacitor and the initial voltage, say Vc of 0 minus is there, okay, then now you can represent this particular capacitor with equivalent circuit, equivalent model. Say impedance is 1 by SC. Okay, so it will be a capacitor 1 by SC and a voltage source, right? The sign will be positive on top side and the negative on the bottom side. Okay, and value will be Vc of 0 minus divided by S. Now similarly you can convert this particular voltage source into a current source. Okay, so it will be a current source and in parallel with this capacitor. Okay, so the value is 1 by SC, and the value of current source will be voltage Vc of 0 minus by S, this voltage, divided by the impedance 1 by SC, and this is basically C into Vc of 0 minus. Okay, so this is the equivalent model. Okay, now let us see how those things are important and useful in the circuit analysis. So suppose you have a voltage source here, say 16 volt, and a switch is there, and it was closed until till t equals to 0 minus, and opened it at t equals to 0. Okay, and as resistance is there, say 4 ohms, and an inductor of 1 Henry, and a capacitor, say 2 farad is there. Okay, and suppose you need to find the voltage across the capacitor, say Vc of t for t greater than 0. Okay, so in this case, first of all you need to find the current, initial current IL of 0 minus, and of course the plus minus Vc of 0 minus. Okay, so IL of 0 minus, you can see this is basically 16 by 4 ohms, because the at DC the inductor is short, so this is equals to 4 ampere, and your Vc of 0 minus will be simply 16 volt. Okay, now you can do you can draw the equivalent circuit. So a resistance 4 ohms, inductor in parallel with the current source. The value of the current source will be IL of 0 minus, this is 4 divided by S, and it will be simply S because L is 1. Okay, and the capacitor, and 2 means 1 by 2S. Okay, and a voltage source plus minus. Okay, and it will be your Vc of 0 minus 16 divided by S. Okay, and so you need to find the voltage across the capacitor. This means this voltage. Okay, this particular voltage, say Vc of S, and please don't make mistake in this particular stage, because while finding the voltage across the capacitor, if you ignore this particular voltage, then your answer will be wrong. Okay, so the voltage across the capacitor in this Laplace domain is basically the voltage across these two components. Okay, so this is basically Vc of S. Okay, so now in order to find this voltage, initially you need to find this current, this loop current I of S. So in order to apply this the KVL in this loop, it is better to convert this particular this parallel combination of this current source and inductor into a series combination. Okay, so here is 4 ohms and inductor, so it is S, and a voltage source, the plus minus, and it will be 4 by S into S, simply 4. Okay, and you have this capacitor, so 1 by 2S, and a voltage source plus minus 16 by S. Okay, so this is the circuit. Now you can simply apply KVL in this loop, and you will get the value of Is. Okay, and from that you can easily find Vc of S, that is equals to your 16 by S plus minus I of S into 1 by 2S. Okay, here this minus is basically because current is flowing from down to top, so on the down side it will be positive, on the top side it will be negative. That's why the negative sign will be there. And for the 16 by S and this particular source, it is simply it will be positive. Okay, so hope you understood this concept. Thank you.